like this lesson because it's, you know, it's calculus. It's definitely moving up into the higher level of thinking, and most people really rock this test. Okay, so if I asked you to find y prime, also known as dy dx, of this, could you do it? Okay, throw it down real quick. Do you get 3x squared minus 6x? Yes, no, maybe so? Are we cool? Yes? Now, that was what we called the first derivative, because there are actually more than one derivative available. If I wanted you to find the derivative of the derivative, the way I would indicate that is y double prime, or through that symbol. These both indicate finding a second derivative. In the real world, there are many, many, many uses of finding more than one derivative. And I'm going to give you an example of one right now. Some of you may be like, oh, that's cool. Some of you may be like, I have no clue what you're talking about. Are any of you all in physics or have taken physics? A few of you all, right? So in physics, and I don't know whether you've gotten to it yet, if I told you I have a position function, right? And I always try to liken it to driving a stick shift, okay? If I'm sitting in a car and I'm not moving in the parking lot, right? Where I am is the position at where I'm at. Does that make sense? So if I want to figure out, like, form an equation that gives me that, I'm good to go. Cooper, put your phone away. So we have a position function, okay? So if I know where I'm located, if I start to move my vehicle, okay, so the movement from the position, the change of position, is what we refer to as velocity. Does that make sense to any physics people? Yeah? Position, start to move, it's called my velocity. The change of my velocity is known as acceleration. As I start to move, I could speed up or I could slow down in that vehicle. Does that make sense? So we have position, velocity, acceleration. There's actually one more in physics. I don't know whether they give that to you in physics here, but the last one is referred to as jerk. Position, velocity, acceleration, jerk. Think about me driving a stick shift. I'm in a position, I start to move it, my velocity happens, I accelerate, and then things go awry. What happens to my vehicle when I don't get it into the correct, I start to jerk that thing, and that's what that is. That's me driving stick shift, guaranteed. Okay, so position is your y, it's your f of x, it's your function, whatever that is. The change of position is your velocity. It's your y prime. So if you are given a function in physics and they want you to know the velocity of it, take a derivative of it. Plug in your value. You'll have your velocity. Your acceleration is the change of the velocity. It's your double prime. And then last but not least, your jerk is the change of acceleration. You go from fast to slow to fast to slow to fast to slow. That's the jerk. All right, are we cool? So that is a real world application of derivatives and the ability to take more than one. So how does a derivative of a derivative look? So if I have my first derivative is 3x squared minus 6x, the y double prime, or d squared y over dx squared, is actually derivative of this guy. And you probably could do it right now without even thinking twice. What is the derivative of 3x squared?
6x.
You guys are feeling good about that. What's the derivative of minus 6x? There's your answer of your double derivative. What do you think? Horrible. Not horrible at all. Y double prime, y triple prime. What would the triple prime be here?
6.
Done. Okay? So that's the idea behind. So this particular worksheet that you have, sometimes we'll say find d squared y over dx squared. just take a derivative of the derivative and you're good. Are we okay with that? Okay, so I wanted to show you that it looks horrible, but it's really not bad. So there's one more thing that I want to do. So I told you there's algebra involved, lots of algebra. So oftentimes we can algebra it first. We could clean that guy up. We could come up with the purified version of whatever they give me and then derive. Sometimes I'm going to give you a problem that you really don't want to have to algebra it first. Because what would the algebraing of this, what would I have to do to clean it up first? Raising it to the 7th power. I could do what we did last week. Beautiful. I could use that binomial expansion and expand it out. How many terms would this guy have? It would have 8 terms. And then if I asked you to clean it up a little and then derive it, you would derive term 1, term 2, term 3, term 4, 5, 6, 7, 8. Sounds like a blast to me as well. However, it seems like a little bit of a time-consuming aspect, right? So I'm going to teach you something called the chain rule. Okay? The chain rule allows you to take something that is contained. What do I mean by contained? This to the 7th power. That's contained to the 7th power. Other examples, something like this. What is this guy contained in? Square root. How do we write that as an exponent? To the 1/2, right? To the 1/2 power. Okay, what about this guy? What is it? -2. I would rewrite this as 2x minus 5 to the -2. Because what I taught you yesterday is you can never, ever take a derivative of this guy in the denominator. Guarantee on the test on Friday somebody will. I'll cry. Not out loud, but I'll cry a little. Just know, you have to rewrite it first, okay? So, contained, 3 different versions. The chain rule is rather cool. So what the chain rule does is it takes something that's contained. Okay, are we cool so far? Okay, so it's going to take something that's contained, and to take its derivative, you're going to take the exponent and bring it to the front. Does that look familiar? Power rule like, right? And the way that I say it in my very professional way is I'm going to take this stuff in the inside, I'm going to call it junk. Whatever that junk is, you're going to rewrite the junk. I don't care what it is, you're just going to rewrite the junk. Okay? In this case, I have ax plus b. It could be like x squared plus 2x plus 5 in the middle. That's junk. Rewrite it. So exponent to the front, rewrite junk. Subtract 1 whole from the junk. Does that look remotely familiar? It's like the power rule coming into play. The only thing that changes it and makes this a chain rule instead of a power rule is I look at the junk. Whatever that junk is, I take its derivative in my brain. What's the derivative of ax plus b? It is just a. Like if this was 3x plus 4, the derivative would be 3. If this is 1/2 x minus 4, it would be 1/2. Does that make sense? So then I'm going to take and find whatever that ax plus b is. I'm going to put the derivative of it right next to it. Okay? So the rule says take exponent, bring it down, rewrite junk, subtract 1, take derivative of junk, and just attach it to it. Seems hard, but it's really not bad. So if we're looking at this first guy, okay, tell me what the junk is in this first guy. Y'all cool with the junk, right? What's the junk of this guy? 2x plus 1. What's the junk of this guy? 2x minus 5. Are we all cool with the junk? Okay. So let's find dy dx of this using chain rule. So the chain rule says take exponent, bring it to the front, rewrite junk. What do I do to my exponent? -1. Okay, cool. And then in your brain, take the derivative of the junk. What's the derivative of the junk? 3, indeed. Can you clean that up a little bit? What can I do to make it prettier? 3 times 7, which is? So 21, 3x minus 2 to the 6th. Done. What do you guys think about chain rule? It's really, really simple. It's good. I wasn't going to show it to you, but why make you do something to the 7th power when you can do this? Okay? So go ahead and find y prime for this guy on your own without me. Here is 1/2 2x plus 1 to the negative 1/2, yes? Yes, 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 yes. Times 2. Because I took a derivative of the junk on the inside. Cleaning that up a little bit, what's 1/2 times 2? Just 1. So my answer is 2x plus 1 to the negative 1/2. Or I could flip it down and make it 1 over that. How do you guys feel about that? We go? Okay, how about this guy? Did we do it? No, not yet. -2, rewrite junk on the inside, subtract, derivative of the inside is 2. Are we feeling good? So -4 times 2x minus 5 to the -3. Are we cool? Yes, we're good? No? Yes. We good? Are we feeling okay? All right, how about this one? I don't know what happened then. 2 over okay, rewrite that for me first. Make sure we rewrite it correctly. You rewrite it. 2 parentheses. Good job. Any questions about that? Are we cool? Yes or no? Maybe so, yes. Okay, so go ahead and find dy dx. Decent? So 2 goes for the ride. Are we cool with that? The -5 comes to the front. I rewrite the junk on the inside. I subtract 1 whole. And then I derive the inside. What is the derivative of 3x squared plus 1? 6x. All right, how do we feel about that? Yes? Okay, now, can we clean this up a little bit? The 2, -5, and 6x can all multiply together. What would that become? -60x. And then I have 3x squared plus 1 to the -6. And I could go one step further to make it prettier. This is good. -60x all over 3x squared plus 1 to the 6th power. Would that work? That or that is sufficient. Yes.
Okay, so you can just leave it with the
Absolutely.
exponent.
Absolutely. Sometimes they're going to say, find the gradient when x is 1. If you're plugging a 1 in here, it's a little easier here than here, but, you know, it's up to you all. Okay, 2 more examples and then I'm done teaching. Yes.
Does that say curve?
Yeah. I don't think I made it any better. I don't know. Maybe a little better.
I just want to make sure.
The handwriting is awful. I do the best. Okay. Up until now, every problem that we've gone over, if I say find the gradient, bless you, I know that we take a derivative and then normally I give you a value for x. Does that make sense? Like x equals 1, an order pair like 1, 4. Okay, what in the world am I doing? Right now I'm not giving you an x value. Where the curve crosses the y-axis. So what's another name for where the curve crosses the y-axis? The y-intercept. So what do we know about the y-intercept? X is 0, right? So without me saying, by the way, I'm giving you an x value, I'm giving you an x value. Does that make sense? So don't be discouraged by descriptions of that, like where the x crosses, where we cross the x-axis, where we cross the y-axis. We have to have that algebra knowledge base of what that means. Okay, so find the gradient. What do I do first? For this guy, I'm gonna find y prime, but before I do that, I can't do it looking like that. I gotta rewrite it. Because I know I can never, ever take a derivative of it in the denominator. I promise 2 of you will on Friday. Okay, I just guarantee it. It happens every year and it makes me want to cry a little. Okay, so now find y prime. Are we feeling comfortable with the chain rule?
Yeah.
It's not bad, right? Chain rule is like 6 weeks into derivatives. How'd that go for y'all? Yes. Did everybody remember the derivative of the junk on the inside? It's just 1 in this case. Doesn't really matter at that point, but I wrote it out. So, do you agree that I could rewrite this as negative 12 over x minus 1 cubed? I prefer it to look like that. Now, I want to know what is a gradient when it crosses the y-axis, hence when x is 0. So what do I do? Plug 0 in. So I've got negative 12 over 0 minus 1 cubed. So negative 12 over negative 1, which is just 12. What do we think? Yes? Cool. One more, and then I'm done. So up until now, I've given you an equation and I've said find the gradient when x equals 3, or when x equals 2, or when the ordered pair of 1, 4. So up until now, I've said here's an equation, find the gradient. So what is this problem doing? It says here's the equation, I'm telling you the gradient, I need to know what the original x and y were. How do I know it's asking me that? What's the specific word that's saying, tell me what the values of x and y are? Coordinates, right? So it wants me to find the coordinates. Be understanding that once in a great while, it'll say, find the x coordinate of this, right? So if I'm finding just the x coordinate, I'd be good with that. This one in particular is saying, find the coordinates, which means it wants an ordered pair of x and y, okay? So this is a little bit reverse of what we've been doing, where we took an x, stuck it in, found a gradient. This is, here's the gradient, find the x. So the technique is very similar in nature. For me to be able to find a gradient, I need to have a derivative. So the first thing I'm going to tell you to do is take a derivative of this thing. So go ahead, take a derivative. I would rewrite it first because you're going to use a chain rule. So, she just informed me I have less than 3 minutes, apparently, because I talk too much. So this is one we'll finish tomorrow in class, but